In this section, we're zooming in from RWAs in theory to RWAs in code. You'll see how to design token contracts, wire up Oracle and data pipelines, and then layer on the analytics and risk tooling that real protocols rely on. Smart contracts are powerful, but they're blind to anything that isn't in their state or fed through an oracle. Real-world assets live in a messy off-chain world of legal entities, bank accounts, documents, and people. The bridge between those worlds is a trust boundary. Designing RWA systems really means designing that bridge. Who you trust, what they report, how fast they report it, and what happens when they fail, lie, or update data late. When you tokenize real-world assets, the core rule is no tokens without matching off-chain value. First, dollars or other assets move into a regulated off-chain entity. That entity runs KYC and investment checks, and its systems ping the blockchain through an API. On-chain, access-controlled smart contracts decide who can mint, burn, or pause tokens. Minting only happens after the off-chain event is confirmed. Supply is permissioned, with hard caps and circuit breakers, so every token is anchored to real settlement, not an algorithm. Now let's look at secondary trading, which works like tokens flowing through a pipe with compliance valves. Before every transfer, the smart contract checks an identity registry. Are both wallets whitelisted? And is this jurisdiction allowed? If yes, the valve opens and tokens move. If not, flow stops instantly. A human compliance admin controls the registry and rules off-chain. The smart contract simply enforces those rules on-chain automatically for every transfer. This separation keeps regulators comfortable without killing composability. When a real-world asset produces cash, the protocol's job is to translate that into predictable on-chain payouts. Off-chain cash is first converted into a stablecoin and sent into a distributor contract. A snapshot or checkpoint fixes who is entitled to what at a specific cutoff time. Before investors receive anything, the system automatically peels off management and performance fees. From there, yield can be pushed directly to wallets, or users can save gas by calling a claim function to pull their rewards. Compared with standard DeFi tokens, RWA security tokens flip many assumptions. DeFi assets are simple, open, and immutable. Anyone can transfer them. State only changes through fixed logic. There's a single balance, and if you lose your keys, that's it. With RWAs, transfers can be gated by KYC or sanctions checks. Contracts usually stay upgradable to follow regulation. Balances may be partitioned into tranches, and admins might be able to reverse or reassign tokens after legal disputes. For RWAs, the oracle acts as a translator between messy off-chain reality and clean on-chain logic. Multiple data sources feed in: market prices, legal or custody records, and accounting statements. The oracle normalizes them, timestamps them, and attaches proof so smart contracts can treat the result as a single, verifiable fact. The cadence is slower than crypto price feeds, and the payload's richer. Things like NAV and status fields, not just prices. Architecturally, updates can come directly from issuers or via independent oracle networks. Real-world assets don't arrive as neat, on-chain objects. They show up as PDFs, CSV exports, and legal docs, all with different formats and naming. The job of an RWA data stack is to extract those sources, run them through an ETL engine, and output a single canonical schema: positions, cash flows, and risk metrics that every app can understand. From there, the same normalized data can be loaded on-chain via oracles and off-chain via APIs, keeping analytics and contracts perfectly in sync. Once RWAs plug into DeFi, they essentially become new collateral types plus new data feeds. The RWA token supplies collateral into lending markets like any other asset. A NEV oracle keeps pricing and state aligned with the off-chain portfolio. On top of that, you add safeguards. Collateral factors and LTVs adjust based on volatility. Circuit breakers pause activity if oracle data breaks. With those basics in place, automated strategies can rebalance between RWA exposure and crypto-native assets, targeting the best risk-adjusted yield. To make RWAs usable at scale, you need an observation layer, a clean, queryable view of what's happening across all pools and chains. Raw on-chain events are noisy and fragmented. Indexing turns that firehose into structured metrics like TVL, NAV, yield paths, and drawdowns. Once this data is warehoused off-chain, You can build tailored analytics for retail users, institutions, and protocols. Shifting from DeFi native risk to RWA risk really means asking three things: who might not pay? Can I exit when I want? And how do rates or markets hurt me? Concentration charts and heat maps show where credit risk is clustered by sector, borrower, or geography. Maturity ladders reveal liquidity risk, when loans repay versus when investors can redeem. On top of that sits market risk, how sensitive the structure is to interest rate moves and macro shocks. Reconciliation is where RWAs either earn or lose investor trust. In practice, you're constantly comparing two ledgers: the legal register of who owns what off-chain and the token ledger on-chain. A reconciliation script runs on a schedule, pulls both datasets, and flags any drift in supply, NAV, or holder balances. From there, you wire alerts into Discord, email, or dashboards and publish a public reconciliation log so anyone can verify when issues appeared and how they were resolved. You can now see this blueprint as a full pipeline, wiring real-world value into Web3 and back out to users. At the bottom, assets and legal claims generate data and cash flows. The bridge layer cleans and feeds that data into on-chain logic, token contracts, compliance controls, and payout distributors. DeFi apps then plug into those tokens with money markets and vaults. Finally, analytics, indexing, and risk dashboards watch everything. Robust RWA systems keep all 5 layers synchronized, or the whole structure drifts away from reality. Think of your first RWA contribution as a 90-day ramp. First, just observe. Mirror existing protocols with dashboards or data pulls until you intuitively understand how value and risk move. Next, plug in, integrate price feeds, build small adapters, or automate reconciliations so off-chain reality and on-chain state stay aligned. Finally, step back and design reusable templates, cross-protocol analytics, or compliance components. You don't need to tokenize a new asset to be valuable. Start by upgrading the plumbing.